Okay, I think it's time for us to start. Good afternoon. I'm John Grayling from South Africa. Very welcome to everyone that's joined in either live or many people said they would be watching this recording. If you are watching the recording and you don't have the Word document I refer to, please contact me and I can email it to you. Just before I start, just a disclaimer, I'm talking to a very diverse audience, people that have never seen Rangers before, people that have played probably all the levels, people that have never coded before, people that are very professional software developers. So bear with me, I'm going to try and cater for everyone, but I need to assume that some people listening to us today have no experience in the game nor in coding. Okay, so the main purpose for this afternoon is the fact that AWS and communities made it possible for us to send some of our Rangers games to Europe. And as far as I know, there will be people from, I think, around 20 countries across Europe playing Rangers in the coming weeks, which is the EU Code Week. For the people from Africa, South Africa, and Uganda, we have our Africa Code Week, and there's a similar EU Code Week in Europe. So first of all, my gratitude towards AWS and communities that made it possible for us to make 200 games available to people in Europe at no cost as part of EU Code Week. I just want to check there's a chat. Okay, so it's just a hello. For those of you who don't know, these are the countries that are people from these countries registered for this session. It is either live, listening and joining us now, or listening to the recording. So truly the most international training audience we've ever had in the 7 years of Tangible Africa. So welcome to all of you joining us. For the people from Europe, I also invited people from South Africa and Uganda. They're not part of EU Code Week, but they're also interested in Rangers. When we introduced or started with our project in 2017, these were the main objectives that we set out. This is myself and my fourth year postgrad student, Byron Batterson. The main objective of the whole project from 2017 onwards has been to introduce learners to coding concepts. I specifically say coding concepts because these games don't teach you a conventional language like Java or Python. It's the coding concepts that I would teach in the first 6 months of the introductory coding module. And I can safely say most introductory coding modules across the world will introduce these coding concepts to students. Within our context, it was important for us to say we need to do this without computers, without the need of electricity while the session is running, without the need of internet, and as low budget as possible. So we are really trying through this project to have as big as possible footprint and reach as many as possible learners. Well, initially across South Africa, now literally across Africa. There's training happening in Kenya this afternoon, and then from next week across Europe. But there will possibly be people tuning in now that have high resource schools, and the top bullets are probably not relevant to you. But I still think from experience in Ireland and Germany and Netherlands that the last 3 bullets is also relevant to everyone. We cannot assume that many teachers are trained as software developers or programmers. So the purpose of this project is to have an easy entry for teachers. Typically, a physical training session would take 4 hours, and I'm aware of many teachers that got that training 2 years ago and are still running with the project in their schools. The concept of fun is very important to us, especially when working with learners or children that are not necessarily going to become software developers. We don't want to put them off from the discipline. So everything we try to do is normally in groups, and even our training, physical, bit difficult online, but physical is also focused on a lot of fun. But then we did not want to compromise on quality. So there's a few basic rules that we set ourselves out to be, and we don't want to be artificial. What we want to do in this project has to have purpose. And the training I'm going to do today roughly covers the 3 areas that's important to us. The first one is the concept of demystifying coding. Very basic introduction to tell people, and in this case teachers, when we train teachers, what coding is. People are petrified when they hear coding, especially hearing it's going to be incorporated in the curriculum, etc. So we are just kind of saying to them, relax, it's not so complicated. The second concept is we say it's not about coding. It might sound funny. For us, the emphasis needs to be on problem solving, strategy, computational thinking is the fancy word. So we try to emphasize, and even in today's training, that it's not just about getting kids to play a game, learn a few loops and if statements, and that's it. It's merely a tool to introduce learners and to create a culture of problem solving. And then the third very direct one in this training is to obviously to introduce teachers and whoever's going to facilitate to the actual Rangers game. That's me and my student in 2017. Our original app was called Tanks. We were just 2 boys playing in a lab, never thought of the political consequences of having a game called Tanks. So forgive us. So that's why we've translated it into Rangers, which is much more, let's say, political sensitive and can be used across the world. Byron is currently a full-time software engineer at AWS. So the very basic concept, as I said, we're not going to today actually play with the app. Afterwards, you can ask me. There are instructional videos of how to play with the app, and I think I did give it to you. The first link is that you get a challenge on the screen. And in the case of the tank had to move to a destination. Then you have puzzle pieces, and today we're going to refer to them as tokens that you pack out on your desk. You take a photo of them, and those puzzle pieces then become instructions to tell, in this case, the tank how to move. So what we're going to be doing in this session today is play around with the tokens. You can later go and download the videos to actually implement it on your mobile app. And before I forget, feel free to put on chat or just talk to me if I miss something. But we'll have some interaction soon. So regarding demystifying coding, and take this if it's relevant to your scenario, the first thing we start off with is saying to teachers and then learners, obviously, that a computer program, very basic definition, is a list of instructions that tells a computer what to do. A list of instructions that tells a computer what to do. An analogy which I've been using in my first year class for more than 20 years, and there's a well-known video on YouTube, is how to make a peanut butter sandwich or a cheese and tomato sandwich. So you can get the learners to write down a recipe for anything that's very common in your culture. And that recipe then becomes the program, and whoever makes the dish or bakes the cake becomes the computer. So a program is a list of instructions that tells the computer what to do. And we always say start at the beginning. I don't know how popular it is in Europe, but the game hopscotch is very popular in Africa. And the child responds to the numbers in the blocks and jumps from one to the other. So the hopscotch grid becomes the program. The child that responds to the grid becomes the computer. The game Simon Says is another example where the teacher gives instructions, the class responds. There's a game called Twister, and in every culture there are many games. So if you start with a group that have never coded before, we kind of say start here. Try and identify games that are a list of instructions where the learners respond to those instructions. This is also, if you want to, I can email you these sheets afterwards. We call it in South Africa the shoe example, but it doesn't need to be a shoe. So you get the whole class or the whole group to take off a shoe, but if they don't want to, they can take anything else. And you show them these posters and they respond to the posters. So if you look at the top left hand, the child will stand behind the chair and the shoe will be on the chair. Bottom right hand, the child will be on the right hand side of the chair and the shoe on his or her head. Again, a very practical, fun way in a class. You probably might not want to do it to older kids, but we've done it with students and they enjoy it. Is again the concept of as you hold up the posters, they become a list of instructions, and the children responding to the posters become the program. So another variation to this is after you've played it, you give them printouts of the different posters and you ask them to sequence these posters in a specific order so that between each poster only one thing moves, either the child or the shoe. And that makes for an interesting discussion and fun at your tables. I forgot to mention that all our training always happens in groups. We do not believe in any one-on-one training. So you always have groups of 4 to 5. And when they start sequencing the posters, it's a next step in programming. Program is not only a list of instructions. There is some order that makes sense, some sequencing that needs to be applied. So you can't just randomly give out instructions. So this is kind of the first step towards that logic. Now, this is the first activity you got in your Word document. Now, to see whether anyone wants to be interactive. These are posters that are used that tells you how to make tea or coffee if you really want to. And I want you to go to your Word document, if you have it open in front of you, and sequence the posters in the correct order. So sequence the posters in the correct order. I'm going to give you, say, a minute. And if anyone has their posters ready, let me know. I'll stop sharing and you can share your posters if you're up to it. So either in the chat or just come and talk to me and tell me you're ready to share your order. Let's try and have an interactive audience today.
Good day, everyone. So unfortunately, myself, I don't have Rangers with me.
That's
I'm in
okay.
the token.
Yeah.
Yes.
But yeah, have you got the Word document that I sent?
No, can I
Okay.
just check? Where have you sent it?
Yeah, I've emailed it to the people that registered, but otherwise you can just listen. You don't need it at this stage.
Okay, no problem.
No
So,
stress.
thank you. Okay.
Anyone brave enough to share their sequence on the screen? Okay, Mara says, yeah, Mara, I'm going to stop sharing. If you've got the Word document on your screen, would you know how to share your screen with us? Okay, you can talk to us. Go through your sequence.
Hi all.
Hi.
Okay, so in my head, I would say first you get everything ready, then you fill the kettle, then you switch the kettle on, and once it's boiled, you're gonna pour the water in the cup, add the sugar, add the milk, stir, drink.
Okay. Is there anyone that wants to disagree with Mara? I'm saying this specifically. Is there anyone that, hi, go for it.
I've got a very similar one. So the only images that are swapped around on mine are the third image. So it's fill the kettle, boil the kettle, gather the ingredients, and then I have pour the water, then sugar, then milk, stir, and drink.
Okay, so you gather ingredients while the kettle is boiling. Interesting
Yes.
point. Yes. I'm looking
So
for a third alternative. There's a third alternative, which differs in my own house. So
Can I try it?
go for it.
Okay, like I think the third alternative, then you have to put in the decision whereby you have to ask whether you need sugar, or it depends on the type of the tea that you want to enjoy.
Ah, okay. So you're bringing in an if statement.
Yes, correct.
Okay, good. Yeah. So we don't have much more time, but I'm kind of like this discussion. So the discussion you can have with learners that have never coded before, even learners that have coded, it's sometimes they never think of these things, is that although we said with the shoe example, there's a sequence, there's often more than one correct sequence that can solve a problem. I like the idea of where the ingredients come. That is something I haven't heard before. But the typical difference is whether you put in the milk before the water or other way around. So there's always a debate on that. So this is a very basic example that you could use. Mara, if you could stop sharing, and I can share again, that you could use to explain to people the concept of sequence. But obviously, once you've got these posters, the sequence of posters becomes a list of instructions that tells the computer what to do. So this is all a very basic demystifying code part of the process. Mara, can you hear me?
Yes, I'm hearing you.
Can you just stop sharing,
Oh, sorry.
please?
I thought I
Okay.
did.
It says I'm still seeing. Brilliant. I can just share mine quickly. Okay, so that's the T example. The other one is very generic. In this case, especially if you work with small children that can't write yet, you get them to draw pictures that gives orders on how to brush your teeth, getting dressed, making cereal, whatever you think of. So in this case, they're not just putting out a sequence of instructions, they're actually drawing the instructions. So this is kind of probably the first time that you can tell them you've now written a program. So you draw pictures to show your little brother or sister how to brush her or his teeth, etc. And there's many examples in normal life that you could use. Okay, yeah, so Mara says she thought it's coffee. No, it's unfortunately tea, but that's not serious. Okay. The grid mat is a fun activity. We have it as part of our tools, but this is something that anyone can create on a floor, especially if you have tiles or outside, or even one of these big chess boards. So just remember the grid mat. We're going to look at the different block moves in ranges soon. So before you go to the actual app, you can do this in the physical world. So on the picture you see there, the black cloth and the two little holders on either side of the bottle are walls. So the thing can't go there. The girl is holding a spray bottle, which we call the duck. And the duck needs to get to the water bottle. So the duck is thirsty. So the commands that one would give here would be move forward, turn left, move forward. And you can obviously reorganize the grid mat to make the task slightly more difficult, etc. This is a very physical, concrete way of getting learners into the concept of block coding, which we mainly do in our program. Before I carry on, I said we want people to think in terms of problem solving. Some people call it computational thinking. Other people call it computational thinking, but have other aspects to it. We try and kind of focus on these four components of problem solving. And I'm going to try and show to you that while you're playing the Rangers game and in normal life, these four aspects of problem solving are often very relevant. So if you look at the picture at the bottom left, we show you this photo and we say to you, okay, we want to end up, this is very basic, but just to prove it, we want to end up writing a list of instructions that would draw a square. So we want to write a list of instructions. The 4 kind of components of problem solving we focus on, again, I'm not saying that's exclusive, is abstraction, decomposition, pattern recognition, and then algorithm. So in terms of this picture, abstraction is you say, let's remove everything that's not relevant in getting to the solution. So if you look at the photo, the hands and the pen and the ruler, they're not really relevant in terms of what we're trying to do. So we abstract let's say the nonsense, and we focus on that which is important. That's the square in the middle. The second aspect is decomposition, where you break up a problem into smaller parts. And clearly when you draw a square, it consists of 4 sides. So we decompose the square into 4 sides. Very basic. We notice that every side has the same length. So in this case, I just said 3 centimeters, but it could be anything. So we recognize a pattern, something that is repeated. And then once we've recognized that, we can now write the algorithm or the set of instructions. In coding terms, we call it an algorithm. So it's move forward 3 centimeters, turn right, move forward 3 centimeters, turn right, move forward 3 centimeters, turn right, move forward 3 centimeters, turn right. Now, I know many of you are seeing something here already. Just be patient, we'll get to it now. So at this stage, the algorithm is 8 instructions to draw a square. Okay, so now to go into the ranges coding. It's often also referred to as block coding. Those of you that remember Lego from the 80s and the 90s, it's that kind of thing. I'm assuming that you don't need your app or the tokens. So I'm just going to play around with the tokens on the screen to solve the problem. Those who are interested afterwards that don't know how it works, I can send you the instructional videos to download the app, etc. And then you just need to acquire the tokens. So the app we developed is called Ranges. And in Ranges, what you need to do, you've got a game ranger, that's the car, that needs to throw a net onto the game poacher. So the whole theme of Ranges is to introduce the concept of game poaching in Africa. And this is just the domain pictures. While they play in the app, they will also get different statistics about game poaching. So the way the tokens are sorted to solve this problem is you always start with a start token. Then the ranger needs to move forward. The ranger needs to move left. So now the ranger's car is pointing towards the game poacher, and the ranger shoots the net at the game poacher. Okay. If we look at, I'm just trying to, yeah. So that is the first, just one of the levels, very basic. Please talk to me if you're unsure. I don't want to go too fast. And I've been doing this for 7 years, so I might assume things that you don't see. But in your set of tokens that you pack out on your desk, you must always start with a start token, and then you move the game ranger on the grid. I hope it's obvious enough which way the car is looking at, pointing. In this case, it's pointing, let's say, upwards. Now we've got a next one before we get to our activity, which I want you to do. You'll see, and sometimes when you play ranges, there's a line between the poacher and the rhino. So you're trying to catch the poacher before the poacher reaches the rhino. The way that works is every time that you move your vehicle, the poacher comes closer to the rhino. You'll see that in the app. So it kind of forces you to have what we call optimal code. You can't just go in circles until you get to the game poacher. So if you take too long to get to the poacher is going to reach the rhino before you catch the poacher. Okay, so if we look at this code, it's start. The ranger is looking towards the wall, so it's got to turn right first. Then move forward. We don't like using the word, but that in this case would be move upwards towards the top. But the ranger is moving forward. Then the ranger turns left. Moves forward twice. And remember, in the app, the game poacher will be moving down closer to the rhino as these steps happen. So you'll move forward twice. Then the ranger will point left, so it will point, the car will point towards the poacher, which allows the ranger to shoot the net. Just see. Unfortunately, we can't shoot at 45 degrees. We keep this at 90 degrees turns. Okay, so now I want you to go to activity 2 on your sheet and see whether you can get the ranger to catch the poacher. To see whether on your sheet you can actually maneuver the game ranger to catch the poacher. Throw a net at the poacher. And let me know when you're ready to share. Anyone brave enough? Okay, now it looks like I'm on my own here. Can't wait too long, unfortunately, because we're going to run out of time. So, the ranger, you need to start. Move forward. Turn left. Move forward twice. Turn left. And shoot the net. Okay. Okay, I think Vince sent these. Yep, good, Vince. Thanks for that. Yeah, that's correct. Okay, so the ranger moves forward, turns left, goes forward twice, turns left, points at the poacher, and shoots the net. Okay, activity 3, I really want you to try and do. There's a catch here for those who've never played Rangers before. Don't just give up. See whether you can get the ranger to throw a net at the poacher. Even if you can't show it to me, maybe someone wants to read out their solution. Let's give people time to just think about it. This is a very important trick in Rangers. If you don't know this, you're not going to go much farther than probably level 9. Anyone out there with a solution? Vince, I think you've played a lot, so maybe let's give someone else a chance. Okay, I'm gonna show you the dilemma, and then let's see who can. So you obviously need to start. So if you think logically, it would be start, move forward, turn right, and then you want to move forward 3 times. But the dilemma is, and this is not just because I forgot, in the actual Rangers game, there's only 3 move forwards. So you won't be able to move forward 3 times because then you need a 4th move forward. So anyone just wants to tell me what's an alternative solution? Specifically someone that hasn't played before. It's not as obvious immediately. Okay, looks like I've got a shy class today. So you move forward, and then instead of turning the obvious right, you turn left. And then you can move backwards 3 times. So you reverse into the correct position. And then after you've reversed 3 times, you're just above the poacher. And then you turn left. You now point towards the poacher and you can shoot. Okay. So this trick of turning the wrong way when you know you're going to run out of move forwards is probably used in most of the levels from about level 9 upwards. So it's a very important trick. And when you play with kids, children, learners, don't just tell them immediately. You can maybe put one of these sequences on the grid mat in the physical world, but let them struggle with this for a while. Don't just give them the answer. Because in a sense, this is the first time that they've got to kind of think out of the box. And it's the first time that they're really trying to solve a problem. So you don't want to just give them the answer. I'm just checking the chat. Very, very good suggestion, Vince. Thanks for that. Yeah, we find that kids immediately want to jump to repeat 3 times. Brilliant. So if you want to, thanks for that tip. I forgot to mention that. When you give the tokens to the learners, there's a lot of tokens that do the loops, the repeat and the while loop. Rather keep them back so that they don't have them. Or simply just tell them they're not allowed to use repeat and while. But that's very important. Some kids that have coded before just go in there into the repeat, and then they don't really solve the problem. Thanks, Julie. You agree? Good idea there. So when they reach the correct level where you start needing the loops, you can make it available to them. So for those who've never seen the code, once you have the tokens, there's a repeat and a while loops with times 3, 4, 5, 6 infinite. You'll see them now. You keep them back. Thanks for that. Okay. Now, this one is where the problem we've just discussed. If you look at the ranger now, the ranger needs to move forward 5 times. But obviously, as I said, you only have 3 move forward, so that's not going to help. If they really want to be sneaky, they can move forward 3 times, turn left twice, move backwards 2 times. So that is a long way of getting to it. But this is where you introduce the concept of a loop. In this case, the repeat loop. For people that code often, sometimes it's called the for loop. So you always start with the token start. And now you say to yourself, I want to move forward 5 times. 1, 2, 3, 4, 5. And for that, you use the token called repeat. Now, the repeat token, you need to put something on top of it and something at the bottom. So what you put on the bottom is how... Is there a question? Okay, so what you say at the bottom is what's going to be repeated. What goes on top of the repeat is what will be repeated. You will see when you work with the actual tokens, they fit into each other. I've tried to use colors, squares, and triangles to say where they fit. So a square goes onto a triangle, and they must be the same color. So what we have here is you start, and then you move forward 5 times. So once you've moved forward 5 times, your game rancher will be literally next to the poacher. And then once you've done that, that's it, after the loop. I'm going to create a little space there so you don't get confused. So that's the start. The loop says move forward 5 times. When that's completed, the rancher turns to the right, and shoots the net. Okay. I hope that makes sense. So it's very important to understand the repeat loops. You cannot do the ranges without understanding the loops. What's at the bottom is how many times is something repeated. What's on the top is what is repeated. In this case, it's a move forward. We'll get to it now, but you can put more than one token on top here to repeat. Any questions before I carry on? Because we're getting into the more fasten your seatbelt code from now. Okay. Activity 4. Now again, see whether you can use the repeat to get rid of all 4 poachers. So the tip is you need to shoot 4 times. So if you've got the Word document in front of you, see whether you can set your code to get rid of all 4 game poachers. Any volunteer before I carry on? Okay. So what we do is we start, and then to get into this long line, you've got to move forward once. And then you need to turn right to point towards the game poachers. And now you want to shoot 4 times. So it's something that's repeated. So you take your repeat token. You say to yourself, I want to repeat something 4 times. And what am I going to repeat? I'm going to repeat the shoot 4 times. Okay, let's just see what the chat say. No, Mara, you can only shoot 1, and you're not shooting, it's not a gun, don't get me into trouble. You're throwing a net, and you can only catch 1 poacher with 1 net. So you can't just say, shoot the net and it'll catch all 4 poachers. You've got to shoot the net 4 times. Okay. I'm assuming everyone is with me, because now we're going into the super duper example. Okay, so I want us to look at this example. Can't remember which level it is in ranges. And what I'm going to do now is not just solve the problem. I'm going to also show you how the learner or the child applies problem-solving techniques without really thinking about them. I just need to go back to the chat. Hi, Emma from Italy. Welcome. Thanks for joining us. If you joined late, we are recording this. You can watch the whole thing later. It's good to have people from all over the world joining. Okay, so the first thing that the learner does without really realizing. Okay. So the first thing that happens is the learner says whatever is on the left and the right is not relevant to solving this problem. So you could explain this to them when they're playing the game. I think it's important for people solving problems to understand when they're applying these different aspects of problem solving. So abstraction says, I only need to focus on what's going on in the middle. There are a few interesting levels in ranges where abstraction is quite important because they see a very difficult route, and if they don't apply abstraction, they go through the difficult route while there's actually an easier way to solve the problem. Okay, so abstraction is the first thing that's applied. The obstacles on the sides are ignored. And then what would literally happen in the learner's head or child's head while you're looking at the problem, you'll see, but okay, the car needs to go forward until it gets to that wall, then it turns right. then it goes forward again and turns right, then it goes forward again and turns right. So what's literally happening in this phase is that the player is applying decomposition. The challenge is broken up into 3 separate parts before the shoot happens at the end, obviously. Then pattern recognition happens, because if the player looks at it carefully, it's moving forward 3 times and turning right, moving forward 3 times and turning right, moving forward 3 times and turning right. So immediately there's a pattern that is recognized, and if the player has had experience in loops by this time, the player should say to him or herself, okay, I need to look at the repeat. And the code to solve this, the algorithm, is repeat 3 times. Why do I repeat 3 times? Move forward, move forward, move forward, turn right. Now, this is just an important I just want to check the chats. I'm scared I'm missing something. Okay, thanks, Emma. Very important to check that whatever is repeated, the sequence goes from the repeat loop away. So don't think in terms of reading from the top or from the left or from the right. You start reading the token from the repeat loop away from the repeat. So if you add the repeat, it's move forward, move forward, move forward, turn right. And if you repeat that 3 times, the ranger will end in the bottom right-hand corner, pointing towards the poacher. And then the algorithm just needs to be completed by saying shoot the net right at the end. So you've got a full algorithm here. You've gone through abstraction, decomposition, pattern recognition. They're not always present. They're not always in the same order. So I just took a kind of an obvious one to show the concepts. But now if you want to force the learner further, this move forward, move forward, move forward is also a pattern, because it's move forward repeated 3 times. So anyone that sees this and knows the repeat will see, but I can do this more efficiently. And that is done by using the repeat that says repeat 3 times the move forward. Okay. So make sure you understand this, because the next diagram might confuse you if you haven't done it before. So what's on the right-hand side here above the repeat is 3 move forwards that can be written as a repeat moving forward 3 times. Now notice what happens if you want to take this repeat and you want to make it part of the bigger algorithm. So the first repeat that comes from the start says I must repeat something 3 times before I shoot. So I must repeat something 3 times. What am I repeating 3 times? I'm repeating a move forward 3 times. I'm repeating, sorry, I must get my words correct. I'm repeating a repeat that repeats the move forward 3 times, and then I'm turning right. So this whole thing in the bold rectangle is the part that's repeated by the first repeat. The second repeat inside the repeat is where the move forward is repeated 3 times. Now, I have sympathy or empathy with people that have seen this for the first time. In coding, we call this a nested loop. So you have an outer loop that repeats something 3 times. What is it repeating 3 times? Another loop and a turn right. So the algorithm is now refined to something more condensed, to have a nested loop. And we could debate whether it's optimized. That's another discussion. If you have coders that have programmed before, you can talk to them about whether this is a faster solution than the other one, or whether this is just fancy code. There's a difference between optimized code and code that looks good. And now we get back to our original drawing the square. And I guess you all saw the pattern there, that the move forward and the turn right was repeated 4 times. So in kind of English language, you would say, oops, that's a typo. It's repeat times 4. Let me fix that immediately. Repeat times 4. What do I repeat times 4? Move forward 3 centimeters and turn right. In coding, the word end, or sometimes a semicolon, indicates often the end of the part that's repeated. We don't have that in ranges, but in normal coding, you normally have the word end or semicolon. And this thing that's being repeated in coding is often referred to as the body of the loop. So if we go back to our ranges example, the body of the first repeat is a repeat and a turn right. The body of the inner repeat is the move forward. So the body of the loop is that part which is repeated by the loop. I see no chat, so you either lost or you understand. Okay, this is a trick that is not really part of conventional coding. One could debate that it simulates something else, but not with that purpose. It's called early termination. Now, in early termination, this would be the solution for this problem. I move forward. Remember, we had times 4 just now. I turn right. I have a repeat that repeats the shoot infinitely. Okay, just to see what the chat says. Why is the move forward not in the center but left? Are you referring to this example? Okay, Mara, yeah, let's go back because that's a very important question to ask for people that haven't seen it before. If you look at the repeat here, we normally see the repeat standing upright. So you've got the repeat. On top of the repeat is the move forward that's repeated. Below the repeat says how many times it's repeated. Now, when we go here, the repeat is turned on its side. So the repeat is here. So we go repeat 3 times. What am I repeating? I'm repeating a repeat loop. Notice you come into a repeat. And here you go into a repeat. What's on top of the repeat? So it's not up there. It's on the top side of the repeat, but it's lying on its head now, on its side. So the move forward comes here. That's repeated. And to the bottom is the times 3. So if the move forward was in the middle, there would be no repeat. I would just be moving forward once. Mara, I hope that helps. Okay, Mara's got it. Thanks for the questions. I like people asking. So, early termination. So in normal English, normal maths, what does this say? It says, keep on shooting forever. Never stop. But we've built a little trick in ranges that helps with future activities levels that says, as soon as the last poacher has been caught with a net, the game terminates. That's why it's early termination. The code does not really terminate. The code wants to carry on forever. But the game ranges knows, I've caught all 4 poachers, I can stop. Although the code wants to go on forever. And we had to build in this little trick just to make some of the levels doable. Okay. Activity 5, it's got nothing to do with early termination. Just see quickly, it's just kind of, let's call it revision. What would you do to solve activity 5? For those who can't see the grid, the vehicle needs to move forward 10 times. Okay, now ladies raised the hand. You want to talk?
Good day. Yes, but I cannot share my screen. Can I
No,
just say my moves?
Sure, you can talk to explain your
So
moves.
okay, it's going to be start, and then move forward, and then repeat 5 times, and then turn right, then shoot.
Okay, Yeah, it's difficult to know what you, but it sounds like you've got it right. Just to to check. So you would start, and then I want to move forward 10 times. So clearly something needs to be repeated. So I say repeat. And then what I do is I take the move forward and I put it on top of the repeat, but I don't just put one there, I put two there. So the body of the loop is 2 move forwards. Does that make sense? And if I repeat that 5 times, I'm moving forward 10 times. Okay. So, and then I'm on top, yeah, just above the poacher. Then all I need to do is to turn right and to shoot. Okay, so just to repeat what I've just done. I want to move forward 10 times. In order to do that, I make the body of the loop 2 move forwards, which I repeat 5 times. That will take it forward 10 times. Then right at the end, I turn right and I shoot. Okay, I just want to check the chat. Yeah, that looks good. Right, now that brings me to introduce the while loop. So the one way of looking at this problem is to say I've got to move forward 10 times. The other way of saying it in English would be I've got to move until I hit the wall. So I just keep on moving until I hit the wall, then I'm here. And to do that kind of thing, I use the while loop. So the while loop works as follows. I say start, while, it's another loop. I remember the repeat loop at the bottom here said, how many times must I repeat? The while loop is what we call a conditional loop. And the while loop says, while my path is clear, that's how you would read it. The repeat would say, repeat 5 times. The while loop says, while my path is clear, move forward. Okay, I hope you understand that logic. So the vehicle is just going to keep on moving while the path is clear and stop when it hits the wall. So when it hits the wall, I know where it's going to stop. I turn right and I shoot the net at the game poacher. I hope that makes sense. Now let's go back to our original problem and see how we can do this one instead of using the repeat. So the apologies. So the body of the first repeat, the repeat that says repeat something 3 times, said move forward 3 times, turn right. But if we want to say it in terms of in English, we could also say move until you hit a wall, turn right, move until you hit a wall, turn right, move until you hit a wall, and then shoot. So we need to redefine what's repeated 3 times. So we come in and we say repeat the while loop. So the body of the loop is a while loop that says, the while loop says, while my path is clear, I move forward. So what that while loop would do, it will take the car and let it go until it hits a wall. Once it's hit the wall, it simply needs to turn right. And if you do that 3 times, the while loop and the turn right, the car will end up in the bottom right-hand corner, pointing towards the game poacher, and then you can shoot. Okay, let's see what the chat says. Okay, explain the while loop again. So let's go back to this one. The while loop, let's just refresh the repeat. What did the repeat do? The repeat said, what's on top is what must be repeated, the body of the loop. What's at the bottom is how many times must it be repeated. Okay, So in this case, the 2 move forwards are repeated 5 times. The while loop is similar. It says what's on top is what must be repeated. What's on bottom says when must you keep on repeating it. So if you read the while loop, it says while my path is clear. So if the car starts here, the path is clear, so the condition is true, the car moves forward. Condition is true, the car moves forward. And it keeps on doing that 10 times. Because it says, while my path is clear, I must move forward. Once the cars hit the wall here, the path is not clear anymore. And the loop terminates. So the loop will stop once the car is against the wall just above the game poacher. And then it will turn right and shoot. I trust that explains. Why is it backwards? Path clear on left and forward on right. Mara, I don't really understand that question. It's very important to understand that your loop, your tokens are either upright or lying on their side, and that determines where the other things go. Mara, just trying, I'm not sure which is the previous slide now. If you can just stop me when I'm at the right one.
Hi. I just go back to the previous slide for me, please.
This one.
No, yeah, and one more back.
This one.
Where are we now? No, I don't know where they are now. This one. No. I want the one where the repeat happens 3 times. Go more back. This one.
Yeah.
So it just, in English, it's the wrong way around. So you're saying forward 3 times or 3 times forward. Is there a coding principle going to happen that governs this? I understand it's the way the arrows work, but is there a reason that arrows that we say move forward on the left and number of times on the right?
You see, your repeat.
Up and down. Okay, back to up and down. Okay, I got it.
Don't worry. So if you got it.
Yeah.
Okay. Thank you. Right. Thanks. So that's the while. We're nearly done with the complicated stuff. One last one. And this is the if statement. Now, bear with me I'm going to try and do this slowly. The if statement is this fork here. It's a decision that is being made. Now you'll see the question says, is the path blocked? That means, am I facing a wall? If the path is blocked, I go to the yes route. And the token says, turn to the right. If the path is not blocked, I can move forward. Okay. So if you look at this code now, the if statement is asked. The decision is made 4 times. Okay. So this whole thing, the if statement with the turn right and forward, is the body of the repeat loop. Now, if I ask and execute this if statement 4 times, see whether you can see where the ranger will end up if I've done it 4 times. Okay. So the first time it asks the question, the ranger is not blocked and it moves forward once. The second time it asks the question, the ranger is not blocked and it moves forward once. The third time it asks the question, the ranger is not blocked and it moves forward once. The fourth time, now the ranger is pointing towards the wall, it asks the question the ranger is blocked and it turns to the right. Okay, so you'll have the ranger in the top left-hand corner of that block pointing to the right. Are you all with me? So let's say if I've changed that ×4 with a ×5, the ranger will move forward 3 times, then it will be blocked, it will turn right, and the 5th choice will make it move forward once. So it will be 1 in on the top row. Okay. Now, we've got an infinite loop here, which says we're making this decision infinitely. And then at the end of the loop, we shoot. So if you think of the logic of the questions being asked over and over, the car will move up to the top, hit a wall. It's blocked, it will move, turn to the right. Then it will move to hit the wall on the right-hand side. Because it's blocked, it will turn to the right. Then it will move downwards on the screen. Because it's blocked, it will turn right. Now, there's something wrong with this code. Can anyone tell me what's wrong? What's the problem in this code? Remembering early termination. Yes, it will, the 4th time it tries to move, it will move on top of the poacher, hit a wall, turn right. And then it will go into some funny loop here, never shooting. So the important thing to understand is the shoot is not part of the infinite loop. And remember the early termination rule says the loop, if it's infinite, stops when the last poacher is caught. Because there's no shooting inside this loop, it will go in some funny infinite and it will just keep on trying to move. Anyone wants to tell me what to do to prevent this from being in an infinite loop that never stops? Okay. The trick is to take the shoot and to put it there after you've turned right. So what happens? Every time it hits a wall, it turns right and it shoots. Now the first 2 times it's going to shoot nothing. It will throw a net, but it won't reach a poacher. But the 3rd time when it gets to the bottom here and it turns right and it shoots the net, it's going to catch the poacher and the loop will terminate. Okay. Now this is probably the most difficult piece of code that you'll need to grasp. It gets much more trickier in the higher levels where you've got to put this inside another loop, etc. But I don't have time for that now. You can go and play and contact me if you get stuck on a specific level. I just want to see the chat. Yeah, it's nets all over. But what basically does, you've got to put the shoot inside an infinite loop. Otherwise, it's just going to carry on. So the first 2 shoots will be unnecessary or artificial, but the 3rd shoot will remove the poacher and the loop will terminate. Okay, right, that's the end of the coding. I've just got a few slides to close off with. And as I say, once you start playing, I can send you the instructional videos to help you again. It's kind of a repeat of what I've just done. And contact me if you get stuck on a specific level. Very important, whenever you do this with children, please do it as groups. Never get it. We don't like a child playing on their own. We strongly recommend that you start coding clubs. If this is if you're a teacher or something, where there's regular events where learners come together to play this game, but also to solve problems. There are thousands of problems on the internet. It's not just about coding ranges. It's not just about going into a lab, it's about solving problems. So if you want more info on that, I can send you some links regarding problem solving. We've also developed a compendium of 40 problem solving activities here in South Africa, which we distribute for free to people. Then just as a quick summary of the project, just to encourage you. Since we started in 2017, we've reached over 100,000 learners, mainly in South Africa. We've trained nearly 30,000 teachers. What I've done now in an hour, it can take from 4 hours to a day and a half, but most of that training has taken over 4 hours, 5 hours. In South Africa, we've changed the narrative. And when I'm saying that, we strongly believe that coding, especially at primary school, is not about teaching people how to develop software. It's about problem solving. We need learners that can solve problems in primary school, in the first grades. We don't need learners that can code or that can write programs. So coding is just one tool. And we've changed the narrative in South Africa, I believe, and what we call unplugged coding. We say we can teach the same level of problem solving in schools that don't have computers. And even the best resource schools in South Africa that have computers are also using unplugged coding now to teach problem solving. That's a good question. When they play in a group, obviously they can test each other, but the app will immediately tell them who's wrong. If it's wrong, then the next person can try his effort. That's the nice thing about the app. They immediately get feedback as to whether the problem is solved or not. Our Mandela Day tournament, and I'm going to say more about that at the end, happens every year on the 18th of July. This year we had 16,000 learners playing at about 80 sites or tournaments across South Africa and Africa, with about 500 schools participating. For future reference, we've also developed a workshop where we showed teachers how to incorporate this block coding in their maths classes, introducing various maths concepts. And we're busy working with a local teacher union and training 1,000 teachers across South Africa using this concept also in the maths class. We've also just completed training 600 teachers that work with visually impaired. That's low sight or blind learners. So this coding for Rangers has been translated and redone the tools to use Braille, contrast, bigger tokens for the low-sighted learners as well as for blind learners. And this is my bottom line message to all of you that will be doing this in EU Code Week or in your school. When we talk coding, it's not about sitting in a lab for small kids looking at a PC. It's about kids working in groups, solving problems in group discussions, strategizing, communicating, listening, talking. So what we're seeing in the right-hand side in a very poor school in South Africa makes us much more excited than seeing a bunch of kids sitting in a fancy lab on their own looking at a screen. This is a quote from one of the blind learners that has participated in our tournaments using our Braille. And this kind of drives us. The more I play, the better my thinking becomes. And this whole project is aimed at improving people's thinking, if I had to paraphrase or directly quote, to improve people's ability to solve problems. And I think with any learners up to university, the emphasis should rather be on getting them to solve problems than getting them to write a piece of small code in Java or Python. I'm a programmer myself. I'm a professor in computing for 30 years. So for me to say this is dangerous. But I think at school level, we need to solve problems. We don't need to code software. You've got your few bright sparks, the brilliant guys, the Bill Gateses. They can write software. But for your majority of learners in your class, at your NGO, at your entity, at your group, we want them to solve problems and to think. And for those of you tuning in from EU Code Week, as well as those in South Africa and Uganda, please keep us updated. We love getting photos and stories of what you've done, where you've done it, how the kids respond. And if we get social media friendly photos, we try to post a news post every morning. And we've been doing this now for nearly 2 years. So please become part of the story. Don't just go and play and not keep me involved. Obviously, it's my baby, and I'd like to see how it's used across the world. For the people that want to go further, our commercial kits is the Rangers coding kit for kids from about 8 years upwards. And we also have the boats kit. You can contact ASIA in South Africa. And then for the people in Europe, Creative Hut, where you had to register originally, they will be distributing these kits throughout Europe from probably early next year, maybe even this year. So you can contact them. And then I just want to finish with our Rangers World Cup. And this is an invitation. The South Africans, unfortunately, we already had our tournaments on Mandela Day, so we already have winners and national finals next week. But people from any other country, especially those of you in Europe, if you can put together 2 teams of 5 learners. On the 5th of December, we're having our Rangers World Cup, which will be a virtual event. You won't need to travel anywhere. You just need to have your learners together in 2 groups of 5, and they can participate in the World Cup. 5 December is a very important date in South Africa. It's linked to the Mandela Day because it's the 10-year anniversary of Nelson Mandela's passing. But every year from this year, we're going to have tournaments on Mandela Day. That doesn't work for the Northern Hemisphere because you're on summer holidays, but you can join us for the World Cup on the 5th of December. Please contact me if you think your site can get 2 teams of 5 together to participate. We'd like to see at least 10 countries. Last year on the 5th of December, South Africa participated against Ireland. I really hope we will have at least 10 countries participating. If you're interested in, let's call it, following the story, every day I post a post about stuff that's happening. For example, this week we were in Cape Town. There's training happening in rural Kenya today. If you just want to follow the story, you can either follow the Facebook group Tangible Africa, follow myself on LinkedIn, or you can WhatsApp me. You've got my cell phone number, and you'll get a WhatsApp post every morning about news from the project. Or obviously email if you have any other questions.